In this paper, we present DualVector, an unsupervised vector font synthesis approach with dual-part representation. We propose a new vector representation for each glyph. Each glyph is composed of several unioned dual parts. A dual part contains a pair of positive and negative paths, which are both closed Bezier paths. A Boolean subtraction operation is applied to form the dual part. With the proposed representation, our approach can learn how to allocate these dual parts from only pixelated glyphs and perform both glyph reconstruction and interpolation given the inputs. Based on the font style manifold learned through this representation, we can easily generate new vector fonts by sampling or interpolation. Benefiting from the fact that each part is composed of Bezier paths, our results can be directly exported to digital font formats, such as TrueType fonts. We associate each glyph with a latent code. In the vector branch, a path decoder first maps the latent code to the control points of dual parts, which are further gathered to form a global shape. To train this branch, we randomly sample points in the 2D space and apply a loss on the analytical occupancy field. To further enrich details for the representation, we also adopt an image decoder to reconstruct the image from the latent code, with a typical image space loss to train this branch. Finally, to align the two branches, we utilize a differentiable rasterizer, such as diffvg, to render and optimize the vector contour computed from the vector branch under the image guidance. During the refinement, we devise several strategies to improve the quality and efficiency of our representation. In subdivision, a long curve is split into two short curves at its midpoint. For simplification, we adjurate adjacent Bezier segments if they nearly form a straight segment. In pruning, we simply remove those Bezier paths that only enclose a small enough region. We conduct a font reconstruction experiment on SVG fonts dataset to investigate how faithfully different methods can reconstruct the input glyph images. Multi-implicits and im2vec can both produce vector results given a pixelated input. DualVector could reconstruct both the global shape and local details accurately. We also compare three image-level metrics at different rendering resolutions. Our method surpasses the two alternatives by a clear margin. We also conduct a font complement experiment on the same dataset. Given a subset of the font, that is, the uppercase and lowercase a, b, as the style reference, the target is to produce a complete font set. Compared to other methods, DualVector can not only grasp the overall style of the input references but also generate new glyphs with clear boundaries and sharp edges, achieving the best visual quality. The quantitative results also show the superiority of our method. Please refer to our paper for more results. Thanks for watching the video. Scan the QR code for released code and data.